Hey everybody, welcome back to Advanced Swift 3. I'm Ray Fix. In this video, we'll be talking about error handling. There are several ways of handling errors. You can use precondition and assert to handle logic errors in your code. This is when the logic is actually incorrect. A precondition will fire or an assert will fire. The difference between these two is assert gets removed from release builds and precondition is always in your build unless you do an unchecked build. Optionals are also a way of providing a basic form of error handling. You can, for example, have a failable initializer where the initializer returns nil if the object couldn't be created. This is a good form of handling simple failures, but for more complicated failures, Swift has a first-class error handling system, and that's the throws system. Finally, you can use a type like a result type that will optionally, much like an optional type, either return a value or an error. And that can be useful in asynchronous conditions. Let's look at the basics of Swift error handling. So Swift provides a protocol called error that when you conform to it, you can create your own errors. So here I'm creating the concrete error, file not found. Then if you have a function that can fail, you mark that function as throws. Any function that can throw an error has to be marked this way. And notice that open is returning a file, not a file optional. That's because it'll either throw and fail, or it will return that concrete type. And that saves on having to handle an optional type coming back. Now, when you call the open function, that function needs to be marked with try. And generally that is in a do block that is followed by a catch block. And the catch can contain pattern matching. And if it doesn't, you just get back a magic variable called error that contains the error that was thrown. Now, unlike many exception throwing mechanisms in other language, Swift has you manually propagate the error message. So it's a little bit different. You don't get automatic stack unwinding. And that can be quite useful in the sense that it's a very deterministic system. Let's look at errors more in the demo.
Okay, open your Errors Demo Starter Playground in your Course Materials folder, and let's get started on custom errors. So make sure that you're in the file navigation. Command 1 will get you there. Make sure you're on the page Custom Errors. So the easiest or the simplest type of error is just optional. Let's make one of those. So here I'm opening a file, and because it can't open it, it returns an optional value, and in this case it's nil. But sometimes you want a little bit more information, and you can create your own error types. That's easy. They can be any kind, but we'll use an enum. So here I've created an enum that is raw representable as an int, and it importantly conforms to the error protocol. And that means that I can throw this thing. And it has two cases, boom, which is 100, and bam, which will be 101. You can also use enums with associated values. Here I've made a fancy error that conforms to the error protocol, and it has one associated value with a string associated with that error. Now, how do you throw these errors? Let's do that. So here I have a do scope, and when an error occurs in that scope, I can just throw one of those error instances. And here I have catch, and it will catch it and create a variable called error that I can print out in this case. So I'm printing out that error. Now you can also use pattern matching to do more fancy matching. So let's see an example of that. Okay, so here I am throwing the error boom, and I have two, or actually three catch handlers. The first one catches all types of plain error, and so this is where we're actually ending up. And then I have a catch statement for our other kind of error. And finally, I have a catch all at the end, and errors need to be exhaustive. I need to be able to catch every single error in the system. If I don't have this, actually the playgrounds won't show a good error message, but it has to be exhaustive because the compiler will stop you if you're not exhaustive here. So let's show an example of that fancy error being thrown. So I'm just going to copy and paste this. Throwing it with a message now. And you can see that we're getting into this catch handler and it's printing out the message from that associated value. All right, so how do these work with NSError? For that, let's go to the next page in the playground, NSError. So on this page, I have some stuff already filled in. I am throwing these errors, and these errors will convert to NSError. So let's see that in action by changing this to NSError. So here I am catching this error, and all errors will convert to an NSError. And so that's why this is exhaustive, because all errors will succeed here that are thrown here. And so I'm getting, for the code, I'm getting 101, which is just the enum case value. For the domain, I get the actual model name, and no extra user info is passed. All right, let's see how Kazam works. So I'm just going to borrow this catch handler and replace it here. And we see that actually very little information is conveyed. You get 0 for the code, and the domain just converts over to the model name, which is fancy error, and there is no user info. So in this case, you would probably want to put a special case above this to catch the fancy error and get this value, this associated value here. So how does it work with when you're throwing an actual NSError? Let's see an example of that. So notice when I try to call a initializer here that is going to throw, I actually get an error message that it says this guy has to be marked with try. And that's just to make sure that you are aware of what's going to fail and that you handle it properly. Now I'm just going to borrow this catch handler here. And we can see that it's throwing, we're catching a real NSError in this case. It's a Cocoa error domain, error code 2, and we could even print out the local description. All right, so there's another way of handling errors, and that's with what's called a result type. Now, a result type is useful for asynchronous code where it isn't clear where you should pass back the error information, where it's actually hard to do the try and the catch. So let's see an example. We will create our own result type. So this is a generic enumeration with a success case that just passes on that associated value of type T. And it has a failure case where I pass along a Swift error. So let's create a Swift error. So this is a normal Swift error that we could throw, but let's make a function that instead of throwing, returns one of these special result objects. So this function just checks to see if the value of b, make sure it's not 0. If it is, it returns the failure result division by 0. Otherwise, it returns the successful result. So here, calling it with 0, we see that we get a failure here. And if we call it with successful or good parameters, we get a success with the value. All right, now I'd like to show you a more full-featured example in the next playground page. So switch to File. And this example brings together a few of the ideas that we've talked about in this video series. And it wraps the C standard IO file that can produce lots and lots of different error messages. So here I see that we have, for example, we have an open that returns the file name that couldn't be opened, or maybe there's some sort of positioning error, or any number of these errors. So wrapping that, we have a class, and I'm using a class because it has the lifetime semantics that I want. So when I deinitialize this thing, a dinit will run and close the file. And it wraps using an unsafe mutable pointer, this C construct, which is a uppercase file. And so here I'm opening that file. I'm converting these strings, file, and mode into C strings and opening the file. And if that file fopen returns nil, then I can throw an error. I close the file, I deinit. On deinit of this file object, I close. Now there's a positioning API, and here I am using a nested position structure. Instead, I could have just passed around this int64 everywhere, but this is a better documentation, or it makes it clearer as to what you're passing around as an offset. And so it's better as one of these little types. Now, possibly the most complicated example in this file is the get method, because you don't know how much data you're going to get back and you have to pass a buffer to that data. So here I'm creating a buffer that gets passed along to fgetS. And I just have to choose some reasonable file size and then do repeated reads and paste together those buffers to create a single line. And so the complication that can come into play is if the break between the two buffers happens to be on a Unicode boundary, a strange boundary where it can't decode those strings, you need to do something special. Here I'm basically backing off. I'm doing a retry in case that the boundary of the buffer has hit one of those places where we can't decode. I have an extension which creates a sequence type called a line reader, and that reads in each line as a sequence type. So it makes it nice to work with files on a line-by-line basis. So here's some test code. And first we open the file. We try to open this file and we write some messages to that file and then close it. And here I have a catch handler that has to be in there because of this try. And I'm not letting any throws escape this function. So this function is not marked with throws because I'm explicitly catching all the errors and swallowing them up here. So after I've created this file, then I go back and I open the file for reading and writing in this case. And I'm going through and using that custom sequence type lines and looping through the lines. Now I'm going to loop through those lines again, and because it's a sequence type and it's consumed all of that data, it's just going to return, the next will be returning nil. So it's just going to silently exit out of here. And then finally, just to show that error handling is working here, I am going to get something from the file, but of course we're already at the end of the file. So that will transfer control into this catch statement and we'll print this out. Now let's see this in action and uncomment test here. And it worked. We're printing out all of those lines that we added to the file. We're reading a second time and it quietly fails. And then we're reading using the get statement, and this is actually causing a throw to occur, and we're getting an EOF getting thrown. In this next example, we're using the result type that we defined earlier. So here I'm defining a type of error, which is a integer parse error. And I have a method called SumNumbers. And this is going to just open a file and read the numbers out of that file, add them together, and then pass that to a closure asynchronously. So it's going to do this work all in the background, and when it's done, it's going to pass the sum that it found back to this completion handler here. So I'm on a dispatch of the background queue, and I open the file, set the sum to 0, and then I start reading through the lines. And then I'm using a scanner, formerly known as NSError, to get the line and actually parse out an integer from each line. And if this fails, then I just call the completion handler with that result type of type failure. And I can pass along the line that didn't parse into an integer correctly. If that works, I just keep looping through and summing. Ultimately, I call the completion handler with success of sum. Now, if the file failed to open here, there was no file, for example, this would throw an error, and I would immediately call the completion handler with that error. So here's the actual code that is testing this. I create a file called numbers.txt, and then I write numbers 1 through 10 to that file. And then I call our method with numbers.txt, and this closure here gets called back asynchronously with our result type. And so here, if it's a success, I just print the sum. And if it's a failure, then I print all of the different types of cases that can fail. This is sort of like catch handlers, but I'm using a case statement with different enum types you can see here, and a default statement as a sort of default catch handler. All right, let's see this working. Uncomment that out. And there we see our sum of 55 being printed.
That's it for this video, and as always, we leave you with a challenge. So in this challenge, you'll create a rewind method for file, and you'll also create a method that returns the size of the file. These methods may fail and may need to throw. I hope you've enjoyed this video. Thank you for watching. We'll see you next time.